Hi, let's have a look at adding fractions. Let's imagine I've got 1/5 plus 1/5. When we see it visually, we can easily see that I have 2/5. Bring in another fifth. I've got 1, 2, 3/5. Each piece is 1/5, and I have 3 pieces. If I write this, I can have 1/5 plus 1/5. That's 1/5 and 1/5 means I have 2/5. Notice that I'm not adding the denominator. When we see the pieces, we can see why. I have 2 pieces, that's 2/5. So the denominator stays the same, and I count my numerators. So imagine I've got 1/5 plus 2/5. Well, my denominator stays the same, and I've got 1 piece, 2 piece, 3/5. That's 1/5 and another 2/5. Put them together. 1, 2, 3/5. So we've seen adding fractions is very simple if we have the same denominator to add. The same denominator, meaning each piece is the same size. But what about when we don't have the same denominator? Let's look at this example. Imagine I have 1/3 and 1/5. Let's put them together. What have I got? Well, I've got 1/3 and 1/5. 2 pieces, but they're different sizes. So I can't say I have 2 of anything. I've got 1 green, 1 yellow. 2 what? So it's not quite so straightforward. Let's have a look at what we do in this case. So, my question is 1/3 plus 1/5. I can't do anything here. I can't just add 2. 2 what? What have I got? They're not the same piece. They're not the same size. So I can't do it this way. What I really want is to have the same size pieces, the same denominator. Let's look at how I can do that. You can remember about finding equivalent fractions. Let's see. 1/3. What's equivalent to 1/3? Well, if I multiply top and bottom by 2, 1 times 2 is 2, 3 times 2, 2/6. These fractions are worth the same. I've done the same to the top and the bottom. So let me find out how I can get the same denominator for both of these fractions. Let's start with the thirds. Let's count in 3s. If I count in 3s, I can go 3, 6, 9, 12, 15, 18, 21. So this is my thirds. What about my fifths? Let's count in 5s. 5, 10, 15, 20. Now if I look through my lists, where do I find the same number? Well, I can make 15 from 3, and I can make 15 from 5. So I can make both of these fractions with a denominator of 15. Another way we can see that here is 3 times 5 would give me 15. So let's write this out again. I've got my 1/3 plus 1/5, and I'm looking to make the same denominator. Another name for that is a common denominator. A common denominator, the same number at the bottom. So my thirds here can become 15. Now, how did 3 become 15? How many 3s? Well, 3, 6, 9, 12, 15. That's times 5. And I know that I have to do the same to the bottom and the top. So if 3 times 5 is 15, 1 times 5 is 5. 1/3 is the same as 5/15. Now what about my fifths? I also want 15 at the bottom. How did 5 become 15? Well, 5, 10, 15 times by 3. So if I do 5 times 3 for the bottom, I have to do 1 times 3 for the top. 1/5 is the same as 3/15. Now I have the same denominator, a common denominator, so I can add my numerators. So 15 doesn't change, 5 plus 3, 8/15. So my original question, 1/3 plus 1/5 is 8/15. Let's look at another example of adding fractions. Here I have 2/5 plus 6/20. My denominators are different. I can't add. Remember, that means my pieces are different. Different denominator, different size pieces. I can't just put them together. I need the same denominator, a common denominator. So looking at 5 and 20, what can 5 become? What can 20 become? Well, if you know your times tables, you can recognize quite quickly that 5, 10, 15, 20. I can have 20 as my common denominator. Let's have a look at that. Remember, I'm looking for the same number at the bottom. So 5 can become 20 in the 5 times table. How does 5 become 20? Well, 5, 10, 15, 20. That's multiply by 4. So if it's 5 times 4 is 20, I have to do the same to my top number, my numerator, to keep the fraction the same. So 5 times 4 is 20, 2 times 4 is 8. Now I want 20 over here. Well, I already have 20 over here, so I don't have to do anything. That's 20, it's already 20, and the numerator is 6. And now I have two fractions with a denominator of 20, which I can add. The denominator remains the same, it's 20, and 8 plus 6, 14 over 20. Here's another example of adding fractions. I have 3/4 plus 2/5. First thing to notice, my denominator is not the same. Remember again, that means my piece sizes are not the same. I cannot add them if I don't have the same denominator, if they're not the same size pieces. So I have to find a common denominator. So a number that both 4 and 5 will go into. Well, let me think about the 4 times table. 4, 8, 12, 16, 20, 24. That's my 4 times table. Now let me try the 5 times table. 5, 10, 15, 20, 25, 30. That's my 5 times table. Is there any number that is in both? Well, if I look along, 20. Both 4 and 5 go into 20. So 20 will be my denominator. So I know that I've got 20 here, but what about the numerator? Well, how did 4 become 20? 4, 8, 12, 16, 20. That's 5 times 4. 5 times 4. So I have to do the same to my numerator. I have to times it by 5. And 3 times 5 is 15. What about 5? How did 5 become 20? 5, 10, 15, 20. Well, that's times 4. So I have to do the same to my numerator. Times 4. So I've got 5 times 4 is 20. 2 times 4 is 8. Now I have a common denominator. I can add them. So 20 down here, and 15 plus 8, 23. So I do have an improper fraction, but my answer is correct.